Could you, at any moment, imagine that the conclusion of our universe may mark the beginning of another one? Perhaps even one that is entirely distinct from our own? Speculations about the multiverse are not novel in the realm of astronomy, yet evidence for this theory is emerging. The James Webb Space Telescope has recently provided the first image of a different universe. Since the earliest recorded times, humans have gazed at the stars and pondered the sun, the moon, and the celestial bodies. For early civilizations, the sun and moon were seen as openings in the sky through which light entered a world they envisioned as a flat disk. Over centuries, humanity discovered that we inhabit a sphere that rotates around a star, which is also spherical, along with countless other stars and planets. We are a minor component of an immense universe and an even larger multiverse. Despite having powerful telescopes for about a century, we still do not know everything about space. Scientists continuously uncover new anomalies in the universe. They find answers to old inquiries, yet many mysteries persist. Strange, isn't it? Until recently, we were unaware of who created the universe or why. We didn't know whether the universe had an end or was infinite. With our most advanced telescopes, we have been able to observe approximately 13.3 billion light-years away. When we look, we are perpetually looking back in time because the light captured by telescopes like Hubble has traversed existence to reach us. We perceive the scene as it existed when the light commenced its journey toward us. This investigation into the past is fascinating. Thus, experts have been able to gaze nearly back to the origin of the universe. Or at least, that was the belief for quite some time. Then came the James Webb, the new space telescope from NASA, the Canadian Space Agency, and the European Space Agency (ESA), which began its operations in the summer of 2022. Even the initial images from the telescope provided vital material that ignited lively discussions among researchers. Today, to be precise, there are 6 universes that should have existed at the dawn of time for which there is no scientific explanation. Systems like Glass Z13 supposedly existed 250 to 350 million years after the Big Bang, and that is theoretically unfathomable. At that specific time, only a handful of stars should have been gradually coming together to form entire galaxies, requiring several billion years. What does this imply? Currently, is the hypothesis of the Big Bang incorrect? Or is there an entirely different explanation? Indeed, there is one we might consider, another universe. Here, the image of the system group max J0647 plus 75 reveals a stunning view of a collection of systems, like precious jewels gleaming in the vastness of space. What particularly excites researchers about this image is not only its beauty but the facts it presents. The same area of the universe was previously imaged 10 years ago by the Hubble Space Telescope. However, the quality of that image was not as good, and specifically, the ancient and reddish objects in the background could not be decoded. It was only clear that they existed, which was peculiar enough. The gravitational lensing effect, where small and distant objects in the background are magnified by objects in the foreground, informed experts that these obscured points of light were old and extremely ancient. Indeed, James Webb then revealed astonishing new details due to the triple lensing effect. Galaxies so ancient, so brilliant, and so highly organized that our Milky Way seems rather ordinary in comparison. Today, specialists are particularly baffled by the information regarding brightness power. If the interpretations are correct, these galaxies have formed multiple times more stars than our galaxy. All the principles of astronomy seem to fail. It's as if researchers have constructed all cosmological perspectives around an assumption that now evidently turns out to be misleading. This is a shock for those who believed in the existence of a single universe and expected that everything within this universe could be explained using the scenarios of Einstein's theory of relativity. Meanwhile, various branches of physics have long suggested that it is significantly more rational for us to reside in a universe that is merely one of many, with numerous additional dimensions or universes that could coexist alongside or even within our own reality. These systems could contradict our current concepts since they belong to a completely different universe and exist within a completely different temporal framework. One of the first newly discovered systems was Glass Z12. Celestial bodies are typically named after the observational frameworks through which they are found. Glass represents gravitational lensing, accurate redshift survey, and Z12 indicates the value of the redshift. Each observational group employs slightly different designations, and providing the redshift value of a newfound universe is not obligatory. To laypeople, Z12 may sound insignificant, but astronomers hold their breath with this designation. This value means the system already existed 300 to 400 million years after the Big Bang. Thus, it is indeed ancient and, according to current cosmological theories, seemingly impossible. The discovery of glass Z12 was already celebrated as a sensation in the academic community, but even older and more intriguing galaxies followed. The universe candidate CRS 93316 appears to surpass all the irregularities. This object is so ancient that it existed 250 million years after the Big Bang. However, this object presents another peculiarity. Measurements of redshift yielded two exceptionally rare outcomes. At one moment, the object exhibited a redshift of 16.7 Z, indicating extreme age. Then measurements of nearby objects to CRS 93316 were taken, and based on those, the galaxy displayed an entirely different redshift. The universe appeared as if it existed in two locations and two times simultaneously. Researchers playfully refer to this system as Schrödinger's galaxy, inspired by the famous quantum physicist Erwin Schrödinger, who demonstrated that at the quantum level, at least two realities can exist at once. According to these theories, it's not merely possible to have two universes, but there could be countless more in various and infinite forms. Researchers attempting to grapple with these measurement results and known aspects would still like to believe in a measurement error or even question whether these points of light are galaxies at all. While the spectroscopy assessment to confirm the redshift is ongoing, further data analysis from James Webb's infrared camera system has already entirely ruled out the possibility of it being a low-mass star or an unobserved active galactic nucleus. We should assume that the discovery of CRS 93316 was merely the beginning of what is possible. NASA has suggested that the James Webb Space Telescope hypothetically can detect galaxies with a redshift greater than 20. These galaxies would have existed just 200 million years after the Big Bang. Or perhaps the telescope is observing much further into aspects of our universe, which may confirm that we have encountered a limit of existence unrelated to the Big Bang at all. As of now, we can no longer speak of the dawn of humanity, the universe, or the time following the Big Bang. Rather, we change our phrasing and refer to it as the edge of the observable universe. There lies another intriguing source of light, which displays an extremely high redshift value in our images. To demonstrate that a 2744 Y1 is indeed a galaxy whose light has traveled more than 13 billion years to reach us, a team of scientists has combined the finest telescopes in the world. The Spitzer telescope, Tundra, and Hubble have captured another image of this surprising galaxy by gathering data from various frequencies of light and merging them into one image. Not only is the age and distance of this galaxy captivating, but the rate of star formation exceeds anything previously considered feasible in physics. Despite being several times smaller than our Milky Way galaxy, a 2744 Y1 produces stars at a rate that is several times faster than that of the Milky Way, which is unusual for a galaxy in a young universe. The observable universe currently has a radius of 46.1 billion light-years. Beyond that, there is probably significantly more. The better our technologies become, the further and more detailed our observations can reach. James Webb is hypothetically capable of looking back 13.6 billion years. If the Big Bang occurred 13.8 billion years ago, there would eventually be a limit to our observations. This is because a few hundred years after the Big Bang, the universe would have been completely dark. The first stars are believed to have formed only after 380,000 years. If astronomers continue to find even older galaxies, it will undoubtedly indicate that all previous cosmological assumptions were incorrect. At present, scientists at NASA are acquiring preliminary insights with the new telescope, which have already been remarkable. Nevertheless, we recognize that time usually unveils new truths, and in a few years, researchers could likely derive even more from the telescope's potential. Perhaps then we could finally uncover what genuinely occurred at the so-called dawn of time. While the theory of the Big Bang seemed reasonable for some time, there was no proof to verify its correctness. With the emergence of quantum physics, it became considerably more probable that our universe is an extraordinarily diverse, variable, and potentially intricate realm. Models of bubble universes or pocket universes suggest that our universe is enclosed in a vast bubble, coexisting with many other bubbles of various sizes. The pocket universe theory proposes that within a universe, there exist distinct fragments where similar yet also differing states of being may persist. These pockets might offer access to alternate dimensions or areas of the universe where different laws apply. There are just as many pieces of evidence and clues for these theories as there are for the Big Bang hypothesis. The assumptions of the Big Bang and Einstein's physical principles were established long before the theories of quantum physics emerged. In the future, combining these models could lead to a deeper comprehension of our universe and the multiverse. If this proves accurate, then we may inhabit a bubble universe surrounded by other bubbles, or there might be an infinite number of universes, each with its own unique set of physical laws. This would imply a level of complexity that far exceeds our current understanding of the universe and our place within it. As we continue to investigate and uncover new information, the probability of discovering alternative universes and dimensions becomes increasingly plausible, potentially reshaping our understanding. We might perceive reality itself from an entirely different angle. Delving further into the implications of these cosmic revelations, we must contemplate the broader questions they raise about our universe and our role in it. One of the most critical inquiries is whether the universe we observe is all that exists, or if our perceptions merely reveal a much larger and more complex structure. The concept of a multiverse, that various, perhaps endless, universes exist beyond our own, has gained popularity in both theoretical physics and cosmology. If the recent discoveries from the James Webb Space Telescope suggest the presence of galaxies that challenge current understanding, it may indicate that our universe is merely a segment of a far grander, infinite tapestry. The multiverse hypothesis itself encompasses various forms, each carrying different implications for our comprehension of reality. One notable theory is the inflationary multiverse, which posits that during the initial moments of the Big Bang, different regions of space expanded at uneven rates. This irregular expansion could have resulted in the creation of numerous distinct bubble universes, each with its own physical laws and constants. If this theory is valid, then the universe we observe may be just one bubble in a vast, diverse cosmic foam. Another intriguing idea is the possibility of a cyclic universe. This hypothesis suggests that the universe undergoes an eternal cycle of creation, expansion, contraction, and rebirth. According to this model, the universe we know could be the outcome of a previous universe collapsing in on itself and then re-emerging in a Big Bang-like event. This cycle could hypothetically repeat infinitely. It is merely one way to propose that our universe cycles through an endless series of cosmic renewals. The discovery of remarkably ancient galaxies like GLASS Z12 and CRS 93316 poses significant challenges to our current understanding of cosmic evolution. These findings imply that there might have been mechanisms at play in the early universe that we do not yet fully understand. If galaxies could form and organize themselves so rapidly after the Big Bang, it suggests that our models of cosmic evolution and the formation of structures in the universe may need considerable revisions. This revelation could lead to new theories regarding how galaxies and other cosmic structures develop and interact over time. Additionally, the possibility of observing anomalies that seem to contradict standard physics models opens the door to a reassessment of fundamental principles. For instance, the existence of galaxies with properties that challenge our understanding of dark matter, dark energy, and the behavior of light could necessitate a revision of the standard model of particle physics. This might also prompt a reevaluation of Einstein's theory of relativity and its application on the grandest scales. As we continue to push the boundaries of our observational capabilities, the role of future space missions and next-generation telescopes will be crucial. Instruments even more powerful than the James Webb Space Telescope will be required to probe deeper into the universe and potentially detect even more distant or faint objects. These advancements will help refine our understanding of the universe's history and structure and may provide additional clues regarding the true nature of the cosmos. Moreover, the philosophical and existential ramifications of these discoveries are profound. If our universe is part of a multiverse, or if there are realms beyond our current observational limits, it challenges our very comprehension of existence. This could affect not only scientific theories but also our philosophical and spiritual perspectives on life, consciousness, and the essence of reality. As we learn more about the universe, we may find ourselves reevaluating fundamental questions regarding the meaning and purpose of our existence.